Consider the case of a car rounding a curve of constant radius. The velocity increases from 55 kilometers per hour to 70 kilometers per hour. Because the velocity is not constant, rather it is increasing, it has tangential acceleration. This is drawn as a vector tangent to the curve and in the direction of motion, which we will assume is clockwise. In addition to tangential acceleration, we also have centripetal acceleration pointing inward towards the center of our curve. And this is labeled AR for radial acceleration. Now we know that the total acceleration is equal to the vector addition of the tangential component plus the radial component. Therefore, using vector addition, we can find the total acceleration vector. And there we found the total acceleration vector, and it points slightly forwards. Now consider the case of a car moving around the same curve of constant radius. However, the velocity is constant. Because the velocity is constant, we do not have any tangential acceleration. Therefore, all of the acceleration is centripetal acceleration, pointing towards the center of the curve. And the total acceleration is simply equal to the radial acceleration. Lastly, consider the case where we have same car rounding the same curve of equal radius. However, now the car is slowing down. The velocity is decreasing, so the tangential acceleration points in the negative direction. Additionally, we have the radial component pointing inward towards the center of the circle. And using vector addition, we find the total acceleration, which points slightly backwards.